So continuing further, we will study Zener diode, which can be used as voltage regulator. So Zener diode is a special type of diode whose doping concentration is more compared to normal diode. This is a symbol where we have some tape that represents Zener diode. Okay, and this is the VI characteristics of Zener diode. So Zener diode acts like normal diode when it is forward biased. Normal diode, Zener diode, no difference when it is forward biased. But special property of Zener diode comes when it is reverse biased. Reverse biased means negative voltage is applied. Therefore, in all the circuits, here I can place a resistor in between, which is called a series resistor to limit the current. So, all practical circuits in having Zener diode, which acts like voltage regulator, you will see that positive is connected to cathode and negative is connected to anode. Means it is reverse biased. Okay. So I was saying that Zener diode, special property of Zener diode is in reverse bias condition. And quickly I tell you there are three criteria where we can use Zener diode as a voltage regulator. So the first property or first thing or first criteria is it should be reverse biased. If it is forward biased, we can't use it as a voltage regulator. Second criteria is minimum voltage should be applied when it is reverse biased. So first thing, reverse bias. After reverse biasing, okay, if I give say 1 volt, -1, -2, then it will not act like voltage regulator. There is some minimum voltage specified, Vz. We call it as Vz, okay, or it's called as breakdown voltage. So that voltage should be applied. Minimum that voltage should be applied. If you apply more than that, no problem. Okay, if you apply more than Vz, not an issue. But minimum that much should be applied. So this is the second criteria. Third criteria is the current. Okay, I have made it reverse bias. I have applied the minimum voltage also in reverse bias condition. Third criteria says minimum and maximum current should be maintained through the Zener diode. So in the data sheet we will have minimum current rating, maximum current rating. So the current flowing through the Zener should be between minimum and maximum rating. Then only it will act like voltage regulator. If the current exceeds, then it will be damaged. As we know, this is breakdown point. So here the current can go till infinity. Okay, it can go till infinity. But we don't want the current to become infinity because it will damage the device. Therefore, this plays an important role, series resistance. So we will calculate the current required here and accordingly we will calculate the resistance. Okay. Say for example, this Zener diode is of 10 volts. Okay. Rating. This is the rating of Zener diode. Means it will give 10 volts across it. Say here it is 20 volts. I am giving 20 volts. Or I can give 15 volts, anything. So if you want to find out the resistance, series resistance, then what you should do is, you should apply this formula R is equal to V by I. Okay, so V is 20 minus 10 divided by I. I we will get it from data sheet. Say for example, it is, let us take 10 milliamperes. For simplicity, for example, then we can calculate the resistance. 10 by 20 minus 10 is 10, 10 by 10, so 1 kilo ohm can be taken as series resistor, so that Zener is acting as voltage regulator because current is maintained, required current is maintained, required voltage is applied in reverse bias. All three conditions are satisfied. And the graph also tells us the same thing. What this graph tells us is, when the reverse bias, okay, Vz we have given, okay, and here there is breakdown. So when Zener is operating here, okay, the voltage Vz, okay, it will not vary. Means though the current is shifting, see here, current can be here maximum. Say current can be here 100 milliamperes, okay, or 500 milliamperes. Say current is 500 milliamperes and minimum range is say 5 milliamperes. 5 milliamperes. So though the current is changing here, 5 milli to 500 milli, though it is changing, but still you will see that voltage is fixed. Graph here current change voltage change so here if you have given 20 volts, you give 30 volts. You give 30 volts. This graph tells us that when you give 30 volts, the current will change. Okay, current is 20 milliamperes. Check ಮಾಡಿ 30 minus 10 is 20. Correct? 20 by 1 kilo ohm. So current will be 20 milliamperes. So though current has changed to 20 milliamperes, but voltage across this will be 10 volts only. Voltage across Zener will be 10 volts. Now you make this 40 volts. Input will change, but still output will be 10 volts only. Output will not change. Okay. Therefore, so if I make 40 volts, the current will change to 30 milliamperes, but 10 volts is fixed. The graph is also telling the same thing. You increase input voltage, current will increase, but Vz is fixed. See this line, it is a straight line. If it goes like this, yes, we can say Vz is varying. Or if it comes like this, inside Vz is varying. But this is straight line, saying that Vz say it is 10 volts, then it is 10 volts only. So this is how Zener can be used as voltage regulator. Okay. So you can get some problems based on these simple problems. Okay. They will give the current, or they will ask you the current. They will give you this resistance. Series resistance they will give you. So they will give you 15 volts, and RS they will give 500 ohms. Okay. And this they will give 5 volts. 5 volts. Find the current in the circuit. So you have to apply 15 minus 5 V by R divided by 500. This will give you current. So it is 10 by 500 or it is 1 by 50. Okay. Like this we can find out the current.